Hey guys, welcome to another edition of algebra class. Well, I figured that I'd post some homework examples for this first lesson of Unit 8. Again, this is lesson 1 of, uh, of Unit 8, quadratic functions. And if you're following along so far with the guided notes, this homework will replicate what we've done thus far. I won't do every problem. I'll leave some for you guys to do. But for the most part, if you do have any questions, I have office hours Tuesdays and Thursdays, where you can schedule some individual time to talk with me about it. Please do so if you're confused. You should expect some type of Google form based on this work, hopefully later this week or early next week. And we'll close up this first lesson with that. So, if you recall, we just finished up with the second page of the notes where we actually were able to graph a quadratic function and talk about the properties of that function. Now we'll just kind of review things that we learned in the first 2 pages of the notes. It says first 6 questions are all multiple choice. Question 1 says, which of the following is a quadratic function? Well, we all know, I hope now, that the standard form of a quadratic function is always going to be f of x, which is another way to say y, and it's always equal to an x squared term plus an x term plus a constant. Now it can exclude the x term or the constant, but it must have an x squared term in it, which kind of eliminates a lot of our choices. Now, we obviously know that our first choice is linear. It's just the basic y equals mx plus b where the slope is 3. So it can't be choice 1. Choice 2 is raised to the 3rd power. That's a cubic function. Can't be that. And choice 4 is actually an exponential function, which we have not covered yet, but it's raised to the x power. So that can't be the choice. And clearly here is our x squared term. Now we are missing our x term. However, being that it has that x squared term, we know that it actually is a quadratic function. And if we were to graph it in our calculator, we'd get a U-shaped parabola. And in fact, it would actually cross at -4 on the y-axis. Kind of looks something like that. Question 2 says a quadratic function y equals 9 minus x squared plus 4x written in standard form would be, well, you need to write quadratic functions where the degrees of the terms are descending, meaning start with your highest degree and move down the line. So if I'm starting with my y equals, I first see that I need to take care of my x squared term. And here it is a negative x squared, or negative 1x squared, followed by my x term, which is a positive 4x, and followed by my 9, which is a positive 9. And there is standard form. Again, the exponents are decreasing from highest to smallest, and our last term should always be a constant. Now, if we match up our answer with the choices, we clearly see that choice number 1 should be the answer. Question 3 says, which of the following would be the leading coefficient of f of x equals 6 minus x plus 7x squared? So again, we want to see these functions in standard form. Clearly, our x squared term comes first, then our x term, and then our constant. Now, the leading coefficient is always the very first coefficient you see when it's written in standard form to the term of the highest degree. Now, the x squared term is the highest degree, and the coefficient attached to the x squared term is 7. Our leading coefficient in this case is 7. And again, you must write it in standard form to identify the leading coefficient. Question 4 says, which of the following points lies on the graph? Well, this one's not too hard. I'm going to allow you to do it on your own. We've done things just like this where we're given an x and a y value, and we must take our x and y values and substitute them into our graph or our function or our equation. Now I'm going to do one that's incorrect, and you guys are going to have the job to actually find one that is correct. It makes the equation true. So I'm going to just test choice 3. Y is equal to 0, x is equal to 5, and when I do some math, I have 0 equals 25 minus 5, and in this case, 0 does not equal 20. We know choice 3 can't be the right answer. You guys take the time to work out the other 3 choices and see which one makes the equation true. That's what we're looking for in this problem. The point that makes the equation true. The point that satisfies the equation. If it satisfies the equation, we know it lies on the graph. Question 5 says a quadratic function in particular, or rather, is partially given in the table below. Which of the following are the coordinates of the turning point? Now remember, we look at our output values to determine where the turning point is, our y values. Notice it goes from 10 to 7 to 6. Looks like it's decreasing. And then it looks like it's increasing again, 7, 10, and 15. Notice the symmetry involved here. And notice that 0.06 looks to be where the change occurs. And in fact, that will be our turning point. And in this case, it's actually a minimum. Question 6 says, given the quadratic function shown below, whose turning point is 2, -4, which of the following gives the domain interval over which the function is decreasing? Now perhaps I'll use a highlighter here just to highlight where the function's decreasing. It's moving from left to right in the downward direction. Now, if I'm looking at this, my axis of symmetry looks to be along this line, and my turning point looks to be at 2, -4. Now, domain tells us that we're always looking at our x values. And in this case, our x value is 2. Now, I know that all x values that are less than 2 include this graph when it is decreasing. Therefore, when x is less than 2, the graph is actually decreasing. It's moving down from left to right. Question 7 says, consider the function f of x equals x squared plus 2x minus 3. Now, ideally, you'd graph this in your calculator, and you'd be able to create a graph. Now, I already did. You can't see my calculator, but if you do have your TI, you can plug it in. Otherwise, use the app on the Chromebooks. And I'm going to go right into my table, and I'm going to give you guys the table actually on this. So if you're looking at it, it looks as though I'm going to start at -4. As my x values. And my y values listed are 5, 0, -3, -4, -3, 0, 5, 12, and 21. Now, if I was to actually graph them on my graph, the one first thing I'd like to look for would be either a minimum or maximum. And I hope it's becoming more obvious to you. Looking at my table of values, it's pretty clear that I'm decreasing first, And on the other side of that point, -1, -4, I am increasing again. Now, I'm going to go to that point, -1, -4. I'm going to graph the 2 points directly next to them, 0, -3, and -2, 3. Notice the symmetry that is starting to form with my graph, and I have reached my minimum point. It is the lowest point on the y-axis. I'll continue graphing 1, 0, and -3, 0, -4, 5, and 2, 5. And to be honest, that's enough points to actually graph my function. It looks something like that. A U-shaped curve, better known as a parabola, with a minimum point at -1, -4, which answers part B. Our turning point. Our range of the function will go from the lowest y value, and it looks like it goes all the way up to infinity. Therefore, in interval notation, we're including that minimum point of -4 and extending it all the way to infinity. The zeros of the function are where they cross the y-axis, right? And it looks like they cross right there. I'll let you guys list those points. Okay, and they're just listed as XY coordinates. Letter D, E rather, I'm going to exclude for now. And letter F piggybacks off the last multiple choice question we just did. Now, based on that last multiple choice question, you should be able to determine when the function is increasing, or at least the interval, or the domain for when it is increasing. Now, I'm highlighting the increasing part of the function in blue. Tell me, what would the domain interval be for when the function is increasing? Now, we can write it as either an inequality or as interval notation. I will start both of them for you. If we're writing it as an inequality, we find our x value of my turning point, which happens to be -1. And I need an inequality symbol between x and that value. If it's an interval notation, I know that from that point, -1, all the way up to positive infinity on the x-axis, my function is increasing. So the interval notation is done for you. And determine what symbol, what inequality symbol, would go in place for that inequality domain. And lastly, question G, or rather part G. I'm going to just ask you guys disregard that for now. Now, the last part in this this homework packet here is number 8, and it gives you a table with specific values, inputs and outputs. And it tells you that the turning point in this table happens to be right here, 3, -8. Now, given the turning point, you know that to the left and right of this turning point, the graph is actually symmetrical. So if I have that point 2, -6, I know I must have -6 as my other output value. As my x increases by 1, looks like my output increases by 2. Now, judging by some more symmetry, x increases by 1 again, and we go from 4 to 5 here. And we look like we have that value, or that output value, of 0. Notice the symmetry starting to form here. Next, I change x by, again, 1 value. My output now becomes 10, And I'll do the same thing on the other side of the graph. And lastly, given the output of 24, the x value of -1, I increase one more x value here to give me an output of 24. Notice your outputs are all symmetric. And that answer is part A for us. Now part B asked you to find the zeros of the function. Now the zeros of the function are quite easy to find. You need to just determine when are the output values equal to 0. And generally there's 2 of them for a quadratic function. They cross the x-axis at 2 points. All right, and when they cross the x-axis, the y values are 0. So your points are highlighted in green at this stage, and it's both those points, 1, 0 and 5, 0. And just to clarify, 1, 0 might be here and 5, 0 might be here. And it looks like we have a minimum, and the graph would look something like that. Now, last thing that I want you to look at today, we're not going to do part D, but we are going to look at part C, the function's y-intercept, where it crosses the y-axis. Now, this is a very simple idea that we've worked on since the beginning of the year. When is the x value equal to 0? That's your y-intercept. It's where it crosses the y-axis. There's only one x value here that's equal to 0. And it looks to be right there. That point, 0, 10, is your y-intercept. It's where it crosses the y-axis. And that's it. So I hope you guys learned a little bit from this lesson. It's the first of many quadratic lessons that we have to actually cover. And again, my office hours are Tuesdays and Thursdays. If you want individual appointments to go over some specific work, that would be the time to schedule them. Feel free to email me, reach out, and we'll help you through this. All right? Hope you guys have a wonderful day, and I'll talk to you soon.